recent years, news has circulated suggesting an end to the flanker, arguably the most well-recognized modern Russian aircraft. While the future of the flanker design is unclear, the current variants of the aircraft remain at the cutting edge of agility and beyond visual range capability, notably the Su-35 Flanker M. During the last years of the Soviet Union, Sukhoi designers had attempted to modernize the Su-27 into an air superiority fighter, more adept to modern combat situations. In 1985, a prototype of the new aircraft took to the skies. Designated the Su-27M, it would see a number of improvements. Outwardly, the aircraft had a slightly modified fuselage, along with canards, taller vertical stabilizers, and leading-edge extensions. The fly-by-wire control system allowed for supermaneuverability, capable of pulling 10 Gs and achieving angles of attack over 120 degrees. The original flanker was already capable of achieving similar feats, but these improvements produced an aircraft even more capable in close-range combat. The aircraft also included a new weapons control system, with the new N11 Leopard radar, which allowed for target finding below the horizon. This would allow the Su-27 to operate against targets on the ground. This new radar system was significantly more capable than what was found on the older flanker. The original system, the N1 Sword, could track 10 targets at once, but could only provide targeting data to 2 missiles at a time while aiming at the same target. In contrast, the Leopard could track 15 targets and provide tracking data for up to 6 missiles at once. This alone would allow the flanker to better match other air superiority fighters like the F-15C, which had similar track-while-scan capabilities. Originally, the forward canards were added to stabilize the aircraft due to the greater weight of the new radar. Only later would designers realize the added benefits of the canards. 2 prototypes of the aircraft were produced. However, the disintegration of the Soviet Union resulted in several changes. Under the new Russian government, the program was redesignated Su-35 to appeal to export customers after it had been cleared for foreign sale. At the 1992 Farnborough Air Show, the aircraft was shown off for the first time. After the 2 prototypes were completed, 9 pre-production and 3 production variants of the aircraft were built by 1995. Yet despite improvements, the aircraft would never enter mass production. The original plan had been to mass-produce the aircraft between 1996 and 2005. However, an economic crisis in Russia deemed the project non-viable. Nevertheless, throughout the 1990s, the aircraft would continue to be presented across the world at various air shows in a bid to attract foreign customers. A key moment in the program came in 1995. Consulting with pilots, designers decided to add a thrust vectoring system to further improve agility at low speeds and high angles of attack. The result was a technology demonstrator, the Su-37 Terminator, as it became known. This design attracted a lot of international attention, appearing for the first time in 1996, and performing a number of impressive maneuvers, including extremely tight turns and high angles of attack flight at near-stalling speed. The experimental technology from the Su-37 and Su-27M would play a role in the development of the Su-30MKI, the Indian export variant of the flanker. It would not be until 2002 that the Russian military, along with flanker manufacturer Komsomolsk-on-Amur aircraft plant, would seriously consider the Su-35 program. In December 2002, another experimental design, the Su-27SM, would take flight. This aircraft would be used to demonstrate new avionics systems, and by 2003, Sukhoi had shown interest in further upgrading this concept. The outcome would be an aircraft, once again, bearing the designation Su-35. First completed in 2007, the first prototype would undergo a series of tests over the next few years. Unlike the original Su-35 concept, this would not feature canards or a dorsal air brake, but would include 3-dimensional thrust vectoring. This lightened the weight of the aircraft and shifted its center of gravity further back. A modified, lightened airframe, largely as a result of using composites, yielded a similar takeoff weight to the Su-27M. This new version of the Su-35 was originally intended for foreign customers. Komsomolsk-on-Amur aircraft plant was presenting the design as an alternative export to the popular Su-30MK variants, produced by fellow Sukhoi manufacturer Irkutsk Aviation plant. This new version of the Su-35 was tested under various conditions as a multi-role aircraft. Unlike the Su-30, pilots initially reported that these tests had been a negative experience. They noted that the cockpit layout was not user-friendly for a single pilot trying to sort out air-to-ground tasks. In response, 2 new digital computers were installed to enhance the flight and weapon control systems. The older CRT displays were also replaced with liquid crystal multifunction displays. While it was possible that the aircraft could now adequately perform multi-role functions, it was clear that the real strength of the aircraft, over the Su-30 derivatives, was air superiority. At the MAX Air Show in 2009, while the aircraft was still being marketed as an export model, the Russian Defense Ministry placed an order for 48 production models of the fighter. These first aircraft would be designated as Su-35S. This large purchase was followed up with further government funding to assist in production. In 2011, the Su-35S would take its maiden flight, and by 2015, an export contract had been signed with China. The Su-35S has since become one of the most important fighter aircraft from the East. Designated Flanker M in the West, the first production variants of the aircraft would be delivered in 2013. The initial goal for the Defense Ministry was to introduce the Su-35 as an interim aircraft before full-scale production of the twin-engine stealth multi-role fighter Su-57. The aircraft would first see service in 2016, when it was deployed to Syria. During this period, it was primarily used to intercept aircraft entering Syrian airspace, including Turkish and Israeli fighters. The aircraft was also tasked with strike missions, although details remain unclear about the extent of its engagement and what weapons were used. Nevertheless, this first deployment exposed potential flaws in the aircraft, which were dutifully noted by Sukhoi engineers. The Su-35S uses a modern PISA radar, known as the N-35 Urbis E Snow Leopard. It had been claimed that this radar can locate targets up to 400 kilometers away, track up to 30 targets at once, and engage 8 simultaneously. It is also equipped with a passive infrared search and track system forward of the cockpit. It has been stated that the Su-35 employs a variety of radar-absorbent materials and coatings, resulting in a radar cross-section of 1 to 3 square meters. In terms of armament, the aircraft can wield a variety of air-to-ground, anti-ship and air-to-air munitions. Given its air superiority status, the most important weapons to consider would be the R-37 hypersonic missile and the modernized R-77M. Details about the modernized variants of both missiles remain a matter of dispute. However, these weapons boast a remarkable effective range. In recent years, we have seen a Su-35 use such a weapon to hit a Ukrainian aircraft at over 100 kilometers away. Powering the aircraft are 2 Saturn AL-41F-1S. These are similar to the engines used on the newer Su-57s. These engines allow the aircraft to supercruise at Mach 1.1. At full power, the aircraft can achieve a top speed of Mach 2.25. In terms of altitude, the aircraft can operate up to 59,000 feet, similar to most other fighters. Another consideration is range. Thus far, the Su-35S has a range of 3,600 kilometers, which can be extended to 4,500 kilometers with external tanks, and a combat range of 1,600 kilometers. The aircraft's stores capacity sits at 17,600 pounds, allowing it to carry a variety of missiles and bombs. In its ideal setup, as an air superiority fighter, the Su-35 would be equipped with up to 12 missiles of various sorts. The final consideration is agility. This has been one of the flanker's strengths since its introduction. The advantages of its improved agility is a tighter turn circle, better roll rate and better low-speed handling. Thus far, it seems as though the Su-35, along with the newer canard-equipped Su-30SM-2, have perhaps the best handling characteristics of any Eastern combat aircraft. Today, the Russian Air Force uses the Su-35S in a multi-role capacity. Despite the initial intention of it being an interim fighter, the current plan appears to be to keep the aircraft in service given its capability. A further upgrade, publicly referred to as the Su-35SM, is reportedly taking place. While many designers are slowly moving back towards twin-seat designs to aid in electronic warfare, strike missions and so on, the Su-35 stands apart from many of its contemporaries, namely the Su-30 and Fa-18 being a single-seat aircraft. Its true effectiveness is yet to be fully proven. Today in Ukraine we hear mixed claims. It was reported that the Su-35 played a role in achieving air supremacy during the first weeks of the war, while further into the conflict, extensive SAM coverage resulted in several losses. Nevertheless, it has since proven its standoff weapons are capable of taking down targets at distances exceeding 100 kilometers. While the end of the flanker has been anticipated for years, it is possible that we will see an upgraded Su-35SM before any real move is made to phase out these aircraft. Much like the F-16, F-15 and MiG-29, the flanker remains a most capable airframe and will likely persist for decades to come.